Let's talk about the first one called as RAID 0. It is also known as data stripping. As I was saying, data stripping. The terminology behind this is fairly simple. A data would be divided into blocks, and each block would be stored on a separate disk. In terms of diagram, if we see this, there will be array controller and there will be disks. So now the logic would be fairly simple. Whatever is data coming would come from this place. Let's say there is a data. This data would be broken into block of 1, block of 2, block of 3. So the block 1 will go over here, block 2 will go over here, block 3 would go over here. The positive thing about this is speed and performance. Why speed and performance? For obvious reason, performance overlapping. When you are searching for block 1, block 2 and block 3 will be prefetched and ready for you. This is generally used in high speed animation, video, audio editing, and wherever you require extremely high performance in terms of working. So it is very common to be used, but this does have a negativity to it. The negative part of this thing is it has lack of reliability. Means what? Obvious thing, if one of the disks fails, consider in our case, third disk fails, remaining data only has a block of the overall information, so end of the day not going to be useful. But this is going to be used only where high performance is required. So we shifted to another RAID level. Now talking about RAID 1. RAID 1 is known as disk or data mirror. Now why it is called disk or data mirror, that has a very clear-cut answer. The terminology is very simple. In this, whatever data coming from the top would be, okay, it only has two disks, number one, let's try to understand that. So you don't require this in this case, we'll only have two disks, consider that. So in this case, I'll just rub it off. Okay, sorry, edit kar le bhai. This would be not needed. Now, if you work with, in this there will be only two disks, which one has something which we call as original data, and second is called as the mirror disk. Logic is fairly simple. Whatever data we are going to write would be written over here. But what is not told to us is what would also happen at the next disk. At the next disk also, a copy of this original data is maintained. Now when it comes to this, there are some serious advantages doing this. The most obvious advantage when it comes to this is reliability. Because of this mirror disk, even if the major disk, that is the original disk, fails, everything is mirrored and made available, so that would handle by the mirror disk. The negativity with this although is time to write, because when it comes to time to write, it would take nearly 2x time. Why 2x? Because if you are taking roughly for writing 1 GB around 5 minutes, now my dear, you guys would be using 10 minutes for writing this data, for the obvious reason, because first 5 minutes you'll be copying data to the original, and then next 5 minutes you'll be copying data to the mirror. So that's basically where this is used. This is very commonly used at many places, especially where data is matter. This is used in mostly banks, financial transaction or financial service, or anywhere where data is more important. So basically that is RAID 1. There is 2x time. Another difference, if we want to say, some people do mention this being slower, especially at the time of retrieval data. So that's basically what disadvantage we are seeing.